Hello, 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 hello. Hello, dear students. Am I audible and visible to all of you? Am I audible and visible to all of you? Yes. Hello, beta. Am I audible and visible to all of you? Yes. I guess 1 second. I need to check my connectivity firstly. I guess I'm having some issue with it. 1 second, 1 second, 1 second. Audible, no? But I'm not getting any information no? Now. Okay. Yes, 1 second. So yesterday we were talking about okay RMS. Yesterday we were talking about the RMS value, and we have to write that it is 1 by 2, right? So is there any confusion regarding yesterday's class? Is there any confusion regarding the yesterday's class? Yes? Any confusion about the yesterday's class? Okay. Let's start today's lecture by doing a simple numerical. Okay. So in previous class, we completed what is basically AC circuits or AC current, what is alternating voltage, peak value, instantaneous value, average value, half cycle, full cycle, RMS value. So these things we discussed in the last class. So now let us do a numerical, a simple numerical. By this numerical, we will be starting lecture number 2. And this lecture be little bit uh, lengthier last time, no? So this lecture would be 1 hour plus. This lecture would be 1 hour plus. Okay, look now. So my numerical is, we are having a question, and the question is about current I, and it is equals to I1 sine omega t plus I2 cos omega t. This expression is given to us. We have to find out RMS value. Find RMS value. RMS value. So how to find RMS value? Number first thing, we need to scale it. Number second, we need to do it is mean. Third point, take it as root. So first step, what is first step? Step first is take it as square. So I will write I square, which equals to I1 sine of omega t plus I2 cos of omega t square. This expression is a plus b whole square. I can open it as a square plus b square plus 2 times ab. So here I will write it as a I1 square sine square omega t plus I2 square cos square omega t plus 2 times a b. Okay. Second step. Step number second. We have to take what? Mean. Step second is mean. So I will take I square mean. It becomes I1 square mean, then sine square omega t mean plus I2 square mean, then cos square omega t mean, then plus 2I1 sine omega t mean, then we're having I2 cos omega t mean. Done? Hello beta, do you teach 11th cube craze next month? That means from 15th of next month I will be starting my 11th also. Starting from starting of 11th I will be starting 11th portion. Okay, but that 11th would be from next month. Look now, what is I square mean? Sir, I square mean is I1 square mean only. Okay, so I don't know, need to write it in this way. No, one second. So I will write it as a I1. It is I1 square only. What is mean of sine square omega t? I guess the mean of sine square omega t is 1 by 2 plus it is I2 square, then 1 by 2 plus 0. So the mean came out to be 1 by 2 I1 square or plus 1 by 2 I2 square. Now third step is take it as root. So this value came out to be RMS value. So look, it came out to be I1 square by 2 plus I2 square by 2 root. Or I can write it as a I1 square plus I2 square 2 times root. Okay, so this is my final answer. It is IRMS. So by this numerical, what we can do, we just do a revision of yesterday's class. We did a revision of yesterday's class. Let us take one more numerical, a direct numerical for yesterday class, direct one. If suppose we are having a numerical, a numerical is I equals to 50 root 2 sine 100 pi t plus pi by 6. If we are having any expression like this, so just compare this expression with my standard form. Standard is I naught sine omega t plus phi. So by this expression, what is IRMS? Sir, IRMS, we know it came out to be I naught divided by root 2. I naught is, it is 50 root 2 divided by 2 root 2. So it answer came out to be 50 only. 50 ampere. Shortcut way. So if we are having anything in a derivative formula, we can use it. Done? We can easily use it, no? Done, beta? Okay. So if we are having anything like this, now let us suppose we are having now V versus time. Time t, V. And if it looks like this, t by 2, V naught 0 minus V naught. If we are having something like this, so how to write VRMS? Same. Look, first of all, we are going from 0 to V by t by 2. From 0 to t by 2, my answer is V naught. So I will write here, sir, integrate from 0 to t by 2, value is V naught square dt plus Then we are going from t by 2 to t. So we are going from t by 2 to t. And my answer is v naught square root, so square the dt, whole divided by total time is t. Then I will take it is root is 1 by 2. This is my answer. An easy answer. Simplified answer. Now just simplify it. So look, v naught square, v naught square. Okay. So I will take v naught as a common term now. So I will get v naught square outside. Then integration of dt is t only. So I will get t only. Upper limit is t by 2, lower limit is 0. Then it is plus v naught square. Then it is t only. Upper limit is t, lower limit is t by 2, whole divided by t. Then it is 1 by 2. 1 by 2. So I will take v naught square. Then we are having it is upper limit t minus 2 minus 0 plus it is t minus t by 2 whole divided by t. Then it is 1 by 2. Done. This cancel out. So this one cancel out. So my answer came out to be v naught only. This one is my answer. V naught only. V naught only. So let us talk about a numerical that was asked in AIPMT back in some days, right? Back in some days. So if we are having expression, an expression looks like this now. And my expression looks like this now. This is my expression. Okay. So I guess what is VRMS? Integrate from first term. I will write V naught square dt from 0 to t by 4, then plus integrate from t by 4 to t, then we don't have, it is 0 only, 0 square dt whole divided by t, then value is 1 by 2. It is VRMS. V naught square I will take at outside V naught square, then we are having t by 4 minus 0 plus 0 divided by t, then we are having 1 by 2. T cancel out. So my answer came out to be V naught by 2 only. This one is VRMS. So this was asked in AIPMT question. Was asked in back in some years. Now I don't have the exact date, right? Okay. So let us talk about a different type of numerical, a different pattern now. My numerical looks like this now. Different sort of numerical. Zero, T, 2T, 3T, and 4T. I naught. Find IRMS. So we know that IRMS means I dt from T1 to T2 square divided by T1 to T2 dt, then we are having 1 by 2. Look here, we don't have any I now. We don't have any I here. You can see here I need I, but in the expression I is not given. So what I can do, look, if this angle is theta, so what is y? Y equals to mx plus c. y. Y is which one? It is I. M is tan theta. I will write tan theta. X is T. Okay. C is 0. Done. I. What is tan theta? P by B into T. I. What is P? Perpendicular, is it I naught? Divided by T into T. So I got my instantaneous current. Now I can put the value here, na? Yes, sir. Integrate from 0 to T for one cycle. I square means it is I naught square T square dt. Whole divided by T, then 1 by 2. Look here. I naught square constant, done. T square constant, done. Integration of T square, it will be T cube by 3. Upper limit is T, lower limit is 0, whole divided by T. Then what we are having here, it is 1 by 2. Now you can see here, this T and this T is T cube. So I got here I naught square divided by T cube. So here we are getting T cube by 3 minus 0 cube by 3 whole power 1 by 2. T cube cancel out. So my answer came out to be, it is I naught square by 3, then 1 by 2 only. My answer came out to be 1 naught divided by under root of 3. Hello, beta. This numerical is a very good one. And by this numerical, you got a lot of information how to manipulate your question if I is not given to us. Look here, you can see now, look, I is not given to us, but still we managed to get the answer as I naught by root 3. How? By manipulating the values only, by using the straight line equation y equals to mx plus c. Okay? Write down all these things, no? Write down all these things. Okay. Next numerical. Next numerical. So we're having a current. I is equals to 2 root t. My current equation is like this. My time interval is from 2 seconds to 5 seconds. Find IRMS. Find IRMS. How to find IRMS? So simple. Formula. It is T1, T2, I square dt. Whole divided by T1, T2, dt. It is 1 by 2. T1 is 2, T2 is 5i. What is I? I is 2 root t square dt whole divided by under root of 2, 5. Then it is dt. 1 by 2. So I can write 2, 5. It is 4 t dt whole divided by, it is 5 minus 2. 1 by 2. Now it is 4t square by 2. Upper limit is 5, lower limit is 2. Then we are having 3. 1 by 2. So 2 on 2 to the 4. I have 2 by 3. Then we are having 5 square minus 2 square. 1 by 2. So I can write 2 by 3. 25 minus 4. 1 by 2. So I can write here 2 by 3. 21. Then 1 by 2. 3 1 the 3. 3 7 21. It is 14. Root 14 is my answer. Root 14 is my answer. Root 14 is my answer. I am giving you 1 minute time. So in 1 minute, I hope okay. So you will find these types of numericals in your examination. No? You won't get an easy one. Look, you won't get anything easy in your examinations. You need to be very good in your calculational part. You need to be very good in your conceptual parts, right? If everything is good, you will get a very good rank. If there is some sort of negligence in preparing any topic, there will be also a negligence in your numbers. Okay. So now we are talking about RMS. Do you know what is the real reason behind what RMS is all about? So now I will give you one feel. What basically is RMS? What is basically RMS? Root mean square. Suppose I will get a situation. Here we are having a AC current. This side we are having a DC current. In AC current we are having a resistor. A resistor, here we are having a AC source. A resistance is R. Now here we are having also a resistor with same resistance. Then we are having a battery, that is DC source. Clear? Current I is flowing at a particular instant of time. Current I is flowing for at time. Now it is function of time. What will happen now? Here heat will dissipate. Heat H1. Here H2 heat will dissipate. We are assuming that both heat same. That means if we are saying that heat production in AC equals to heat production in DC. What is heat? Sir, heat equals to I square into R into T. This I1, I square, but in DC the resistance is R times T. Here H2. So H2 is I square, but I is the function of time T. I is the function of time T. So I can write it is I square into R then dt integrate from T1 to T2. Both are equal, so I can write I square dCRT Prashant Rao. Thank you, beta. So we are having I square RT, then it is equals to T1, T2, then we are having I square RDT. R cancel out. Okay. So can I write now I square DC is equals to integrate from T1 to T2, it is I square dt whole divided by T. Then next step is take square root both sides. So I can write IDC equals to T1 to T2 is it I square dt divided by T. Then I have 1 by 2. So now you can see this particular thing now. This one now. I guess this one is same as that of this function. Same. So you can judge from this particular point that my RMS value in a circuit is that amount of DC current which produces same heat in that particular instant of time. I will repeat it. RMS value of a current, that is AC current, the RMS value of a AC current is that amount of DC current which produces same amount of heat if current is flowing through the circuit in a given interval of time. Same. And one more problem is there. Now, I will give a little bit of hint of that. One more problem is there. That is, sir, when we were dealing with the instruments, when we were dealing with the instruments back in chapters, we use voltmeter, we use galvanometer, we use ammeter. Galvanometer, we use ammeter. But these instruments are purely designed for DC current. But if we want these to be working condition in AC, so we can use what? Hot wire voltmeter, and we can use hot wire ammeter. These things work fine in AC and DC. So look, voltmeter and ammeter, these are majorly designed for DC. But for AC, we are having different instrument known as hot wire voltmeter and hot wire ammeter. Prashant Raut. But you ping me a personal message, no? I will just tell you, right? Don't worry about anything. You are having, you can do one thing, now. Go to the channel description part. You will find my Telegram link, no? You can ping me your these things, right? So look, voltmeter and ammeter. We can use these two devices for DC only, right? But if you want the AC to be also measured, so we are having hot wire voltmeter and hot wire ammeter. And these thing is work based on what? Heating effect, right? Heating effect or RMS value. RMS value, because RMS value is also depending on the heating effect now. So you can write the principle of hot wire instruments, volt and ammeter, galvanometer. This is basically on RMS value. Okay, and it is non-linear. One more thing, it is non-linear. Non-linear. Non-linear means it is not varying linearly. No, look, linear means this one. It is not varying linearly. Okay, it is fluctuating. It is fluctuating. It is not that important. No? That's why I'm not going into depth of it. One of the most important thing that you need to learn if you are dealing with the sinusoidal equations, anything, if you are going with SHM, waves, EM waves, AC, you are dealing with the sine or cos graphs, right? So, but that thing you need a phasor and phasor diagrams. You need to be very good. Okay. New topic is you need to be very good with phasor. Phasor and phasor diagrams. Phasor and phasor diagrams. Phasor and phasor diagram. Sir, what is basically phasor? What is basically phasor? Look, I will just ask you one numerical or one question. Now, what this thing represents? Sir, this thing represents addition. Addition. What this thing represents is subtraction, division, multiplication. In the same way, we are having one more mathematical tool, that is phasor. That is phasor. Just like addition, subtraction, multiplication, division, no? We are having one more tool, and that tool known as phasor. That tool means phasor. What phasor basically is, no? You need to understand. Hello, beta. You need to understand couple of things. If your quantity that you are just dealing with is sinusoidal variation, if your quantity is sinusoidally varying variation, first thing. Second part, your rotating vector which you need to take as anti-clockwise in circles. Second thing, length of this rotating vector, that means radius of circle, it gives as the peak value. It is peak value. Then fourth point, projection of y-axis. Projection of y-axis, that will give you the instantaneous value. What is phasor? Quantity should be your sinusoidally variation. Rotating vector, you need to take it as an anti-clockwise in a circle. Third one, length of vector gives you the radius of circle, which is your peak value. And projection of this rotating vector on the y-axis, it will give the instantaneous value. Sir, okay, what is the reason or what is the meaning of it? The meaning of it is like, look now, the meaning of it now, look. So if this is my circle, okay, now look now, central point. So this particular thing, this one is phasor. This one is a phasor. If it is a circle at t equals to 0, your phasor is at here point. After some time, it could be here, no? At t equals to t, it is here. So this angle rotation is theta. Theta means omega t. So if, look now, I will take it as projection. Projection means it is shadow, na? Shadow on y-axis. It is shadow on y-axis? Yes, sir. It is shadow. Look now. If it is peak values I naught, what is sine theta now? Yes, Prashant Rose. Yes, beta. Look, we just started now. We just started phasor. Then after phasor, what we can do now? We had couple of numericals. When you will be very good with these things, then I will tell you how to tell which one lead, which one lag. You be in the lecture up to 12 o'clock. You will get each and everything clear. No, don't be in a rush. Motivation home, beta. I can see your comments, no, but the whole lecture is in English. I cannot explain these things in Hindi. Okay. Look now. What is sine theta? Sine theta is P by H. Look now. Okay. P by H. So what is P now? What is P? Sir, I don't know P is, let's say Y. Suppose Y. What is H? H is I naught. So what is Y? Y came out to be I naught sine theta. Theta is omega t, so Y came out to be I naught sine omega t. So this expression, now this one came out to be I equals to I naught sine omega t. This one. So this thing represents your peak value. This means your instantaneous value. So you are going in anti-clockwise manner. Anti-clockwise manner. Look, it is sinusoidal. Yes, sine is there now. Second point, rotating vector. Yes, it is rotating anti-clockwise. Third thing, length of vector. Length of vector. This one. It is what? Radius of circle, which is a peak value. I naught. Yes. Projection on y-axis. This is projection of y-axis. It is what? Instantaneous value. It is what? Instantaneous value. So I guess it is very clear to you and it is very easy to understand, right? So I guess my equation came out to be I equals to I naught sine omega t. This equation we got from this phasor things. Easy or super easy? Easy or super easy? Now I will tell you how to play with phasor. How to play with phasor. Look now. What is I? I came out to be I naught sine theta. Suppose if theta is equals to 0 degree, so I guess my I came out to be I naught sine 0 degree. I guess my I came out to be 0. Done. Second one, if my theta is 30 degree, so I can write I is equals to I naught sine 30 degree and sine 30 is 1 by 2. I can write I naught by 2. Third one, if theta is 45 degree, I can write I equals to I naught sine 45. So I can write I came out to be I naught or root 2. I naught root 2. Okay. If theta is 60 degree, so my I is equals to I naught sine 60 degree. So my I came out to be, it is root 3 times I naught by 2. If theta is 90 degree, so my I is equals to I naught sine 90 degree. I came out to be I naught. That means my current came out to be what? Peak value. So now what you need to do? Just draw each and every notation in your circle. No, it is not a circle. Okay. Look now. If it is initial means if t equals to 0, also known as phi equals to 0. What is phi? Initial phase. Initial phase. If it is at t equals to 0, initial phase. Now look now. I guess theta is 0. Look, if theta is 0, you can see now, if theta is 0, I is 0. Theta 0, I is 0. So here we have 0 value. Now if theta is 30 degree, if theta is 30, this is my 30. If theta is 30, so it is projection would be somewhere here, no? It is projection is I naught by 2. It is I naught by 2. This angle is 30 degree. If it is 45, this angle is 45 degree. So it is value came out to be how much? I naught by root 2. It is I naught by root 2. Now 60 degree. 60, its projection would be like here, no? 60, it is I naught, it is root 3 I naught by 2. It is root 3 by 2 I naught. Then 90, it is I naught. 90 means this much now. This much here, it is I naught. This is how we can deal with what? Phasor. Phasor, right? It is a phasor. Then in the same way we can go here. So here it is minus I naught by 2. Here it is minus I naught by root 2. Then here it is minus root 3 by 2 I naught. So here it is what? Minus I naught. This is my phasor. How to just have a fun with phasor. Look, you can see now, you can see here now at theta, when theta is 90 degree, when theta is 90 degree, my phasor is highest point at this much. But what is the timing? If somebody will ask you, tell me the time of your phasor to reach your maximum what? Maximum value. So if you need to find the time for I naught means maximum. Okay, I naught maximum means theta is 90 degree, no? Okay, so look, in a circle we are having 360 degree. To complete one circle means t, time period, 1 degree. 1 degree means t divided by 360. But we are having 90 degree. For 90 degree, t divided by 360 multiplied by 90. Cancel out. 3 3s are 9, 3 1s are 3, 3 2s are 6, 3 1s are 3, 3 4s are 12. So my answer is t by 4. In t by 4 seconds, we are getting our maximum value. In t by 4 seconds, we are getting my maximum value. This is how it is how you need to interpret your numericals and you will get your answer. This 90 we got from phasor and this calculation we got from unitary method. If let's say you are having numerical, numerical is like if my I equals to I naught sine omega t plus phi. It simply indicates my phasor starts at phi. So it starts from phi. That means at t equals to 0, my phasor is at this angle. Okay, my phasor is at this angle at t equals to 0. Here it is given to us, no? Sir, give me one more example of this thing. Okay, I will give you now. Suppose my I is equals to, is it I naught sine 100 pi t plus 30 degree. What is the 30? So it is initial phase. Initial phase. That means Look. So it is here now, 30 degree. Now you want peak. I guess peak is here now, 30. So peak is at 60 degree now. So timing to get my peak now. Look, for 360 degree, we are having T. For 1 degree, we are having T by 360. For 60 degree, we are having T divided by 360 into 60. Cancel out. 6 66 are 36. So my answer came out to be T divided by 6 seconds. This is how you need to deal with your phasors. Easy or super easy? Easy or super easy? Easy or super easy? Okay, now sir, one more thing is there. Now we got the value. We got the value. That means this is the time at which I will get my peak value. Okay, this is the time at which I will get my peak value. But here now, one thing is there. T. What is T now? How to get the rid of T? One thing is there, right? Look, we know I equals to I naught sine omega t plus phi. Look, what is omega? Omega is t pi by t. I guess it is 100 pi t now. Look, pi cancel out 2. 250s are. So my t came out to be, it is, 1 second. 1 second, beta. So can I write now? Can I write now? So t came out to be 1 by 50 t. I can write like this now. Done. But here we are having omega t now. It is omega t now. It is omega t. It is omega t. That means t multiplied by. So t cancel out. It is 50 only. So capital T came out to be only 50. Done. So I will write this value now. It is 1 by 50 whole divided by 6. It will be 1 by 300 second. So in this duration, you will get your peak value. In this duration, you will get your peak value. Okay? Easy? Is that super easy? Okay, one more numerical. One more numerical is here. One more numerical. In today's class, we will complete each and every numerical. Okay? Be in the class. Yes, sir. If initial phase is just a time shift, what does it matter physically? Vega, look now. If your phase, right? So if we are just dealing with the circuit now, if it is a minutely disturbed, right? But it varies very significantly. Okay? It varies. Look, it is not depending on that particular time frame, right? When we are just placing that particular values into it now, your answer will abruptly will go very big. So that physically will challenge you. Okay, it is not like that, right? So it seems to be very small, no? But physically, it has a very great significance in your circuits. It need to be very precise. Look now. Suppose we are having a numerical. Numerical is I equals to 15 sine 100 pi t plus pi by 6. We are having a numerical like this. Okay. This one is very unique now. So you need to find now R IRMS. You need to have IRMS. IRMS. Now look, in back numerical, we were discussing what? A peak value. Now we don't need peak, we knew RMS. And we know that if my equation is in the form of my standard equation, if my equation is given in the form of standard equation, right? So my answer came out to be very direct. It is I naught by root 2. So now I need to find my peak value. I need to find my peak value. No worries. It is pi by 6. Do you know what is pi by 6? pi by 6 means 30 degree. So initial phase is how much? Initial phase is 30 degree. So my vector starts from this one, 30. So this one is 60 degree only. Okay. So back one now, if it is 60, so my answer is t by 6. It is t by 6. Okay. But look, it is not like that. Do you know why? Do you know why? We don't need back. We don't need this much, no? Why? We need root. We need root 2. Do you know what is root 2? 1 by root 2. Yes, sir. It is 45 degree. So we need only 45 degree. 45. So this angle is 15 degree. So that simply indicates. So if my 360 degree gives t, 1 degree gives t by 360. So 15 degree gives t by 360 multiplied by 15, which equals to t by 24 seconds. Now I need my t. We know that here, look, it is 100 pi t equals to omega t. So my 100 pi omega is 2 pi by t. So t came out to be 2 pi divided by 100 pi. Cancel out, it is 1 by 50. So my answer came out to be t equals to t. It is 1 by 50 multiplied by 1 by 24. It is 1 divided by 1200 seconds. Very easy. Very easy, no? Good. Okay, one more different now. A different numerical. If somebody will ask you half the peak, if you want to find half the peak, so what is half the peak? Peak, oh look, at 90 degree, we are getting my peak value. But at 30 degree, we are getting my I. I came out to be I naught by 2. I want this thing now. It is half the peak, no? Okay, so look, 360 degree give me the T. 1 degree. 1 degree give me the T divided by 360. So 30 degree gives me what? It is T divided by 360 multiplied by 30. It is 3T divided by 12. Second. Done? Done now? Okay. But look now. Look now. What is omega? Omega is 2 pi by T. Omega is frequency. So T came out to be, it is 2 pi by omega. Done? T equals 2 pi by omega. What is omega now? Done? So I can write it in this way, but we are having one more thing now. Sir, what we are thinking? What is frequency now? I guess frequency is 50 hertz. I guess frequency is 50 hertz, no? In our Indian domestic system, by frequency is 50 hertz, right? It is 50 now. Okay, so by time period is 1 by frequency. So I guess I can write 1 divided by 50 divided by 12. So my answer came out to be 1 by 50 multiplied by 12. So I guess my answer is 1 divided by 600 seconds. One by 600 seconds. Okay, now, okay, look. Now I will just give you one things now. That is, okay, how to differentiate leading and lagging. Leading and lagging. How to differentiate which one is leading, which one is lagging. First of all, to differentiate lagging and leading, both V and I, both should be in sine function. Both should be in sine function. Suppose, case number first, V equals to V naught sine omega t. I equals to I naught sine omega t. Suppose, now, example. The first phase angle is omega t, second phase angle is omega t. So now what is phase difference? What is phase difference? Phase difference means subtract both phases. You can do V minus I or I minus V. What is value? 0. So the phase difference is 0. Shantrao, sir, I also have a doubt that how can a 1D instantaneous value capture the hidden 2D rotating info of a phasor? But I do one thing now. It is very easy things, right? So do one thing now. You can just comment me, right? So you are having my Telegram group. You can just comment me all your doubts. Now I will give you a solution. Don't worry about anything, right? I will give video solution of all these things now. Or we can do one thing. We will have a Google Meet there. Okay? I will give the answer of all these things, right? Don't worry about anything. Okay? Look now. So you can do now. It is not compulsory. You will do this minus this. Okay? You can do this minus this now. Every time the answer is same. That means, look, if V is going in this direction, same, I will be going in this direction. If V is going in the direction, I is also going in the same direction. If V is going in this direction, I is same going in this direction. There is no phase difference. And if you need to show them now in a graphical notation, look now. If V is in this way, now look, if V is in this way, what is I? No phase difference, but we know that V equals to IR. So I equals to V by R. This one is V. So if my R is more than 1, so my I will be less than V. So my graph will looks like this now. My graph will look like this now. You can see now, no phase difference. No phase difference. But value is different. Value is different. Why? Because it depends on R. Also now, it can also start from this thing. Now. It can also go like this. There is no restrictions to it. No restrictions to it. This one is also I. This one is also I. It depends on R. If R is more than 1, I is less than 1. So less than V. Then case number second. Case number second. Case number second. Look, if V equals to V naught sine omega t and I equals to I naught cos omega t. Now here, right, I told you this should be in sine, this should be in sine. So this expression I can write it as I naught sine omega t plus pi by 2. What is phase difference? Phase difference. You can do one thing. You can write omega t minus this phase. It is omega t minus pi by 2. So my answer is omega t minus omega t plus pi by 2. My answer is what? Pi by 2 only. Sorry, it is plus, no? So my answer came out to be minus. Do you know what is minus? Do you know what this minus indicates? Minus indicates that, yes, we do subtract V, then I. But my answer came out to be negative. That simply indicates our direction is wrong. I is leading. My I is leading by pi by 2. Or you can write V is lagging. V is lagging by pi by 2. If let's suppose this is my V, this could be my I. This is my V, this is my V, this will be my I every time it is leading. It is leading. Now if you make a graph of it, right? So look at my graph. This is my V graph, V graph. My V graph. My I is leading now. I is leading by pi by 2. I is leading by pi by 2. Yes, sir. So it came out to be like this. This is my I. This is my V. Very easy, no? Very easy. Look, suppose we are having two quantities, 5, 2. Thus, we are having two ways to separate it. We can do 5 minus 2 or we can do 2 minus 5. 5 minus 2 is plus 3 and 2 minus 5 is minus 3. That means this is wrong, this is correct. So if we are doing 2 minus 3, my answer is minus 3. That simply indicates my 5 is more, 2 is less. The same way, we do this calculation, my answer came out to minus pi by 2. Minus pi by 2 means that my I is leading, my V is lagging. Case number 3. Case number 3 then. Case number 3. Case number 3 is my if V equals to V naught sine of omega t. What is I now? If I is given as minus I naught cos omega t, I will change it. So it will become I naught minus cos omega t. So I will write it as a I naught, then sine, it is omega t minus pi by 2. Done. So what is phase difference now? Phase difference, it will be omega t minus pi by 2. It came out to be pi by 2 but positive. So we do this minus the whole thing. That means if it is positive, so V is leading. V is leading by pi by 2. If this is my I, this could be my V. If this is my I, this would be my V. If this is my I, this would be my V. If you want the of it is graph, if you want this graph, now look now, it is graph. Okay. V graph, then I now. So I guess I came out from like this now. This is my I graph. V graph and I graph. Easy or super easy? Easy or super easy? Huh? Easy or super easy? So now we know that what is lagging, what is leading. How to depict which one is lagging, which one is leading. We know all these things now. Now comes a very great thing. A great thing, that is circuit theory. We are having now circuit theory. In circuit theory, we are having 3 circuits as of now, purely. We are having pure resistor. Pure resistor means if we are having a circuit with only a resistor involved. At a particular instant of time, my current I is flowing. So write KVL. What is KVL? Look, current is going inside. Now I can write minus IR plus it is V naught sine omega t. I will write V naught sine omega t equals to 0. So I came out to be, it is V naught by R sine omega t. So I came out to be, it is I naught sine omega t. Look now. V naught, I naught. What is phase difference? Sir, I guess previous case now, phase difference is equals to 0. If it is I, this should be V. So if you want to make it as graph, V graph and I would be like this, I graph. We do it now. I think we have just completed this one now, this case. Similarly, we are having this case. Done? It's easy now. Very easy. The second case. Second case is if we are doing pure capacitor. Pure capacitor now. Pure capacitor. With capacitance C. Done? With capacitance C. What you can do now? Look. You were right. This side is positive at a particular time. This one is negative. So I can write minus Q by C plus V naught sine omega t equals to 0. So I can write Q by C equals to V naught sine omega t. Q equals to V naught or CV naught sine omega t. Differentiate both times with time. So it came out to be current equals to CV naught differentiation of sine omega t. I can write I equals to CV naught. It will be omega and cos omega t. Then I came out to be C omega V naught cos omega t. Now change this one now. Prashant wrote, beta, देखो, I am in the flow now. Look, beta, you are having a genuine doubt, right? So what basically I want you to just understood now, that is I am doing some different things right now, okay? And you are having some different concept things. If I am going to explain your doubts here now, that will going to create a confusion to my basic students, right? So I request you that you are having my Telegram ID. You can doubt your doubt is there now. We can have a chat there. Don't worry about anything. You can have a thousands of doubts. You can ping me there. Don't worry about anything. I am here. I will give the answers, right? Look now. So what we can do? So look now. Can I write it like I equals to V naught 1 divided by omega c, same, and cos omega t. I will write here sine omega t plus pi by 2. What is Ohm's law? V equals to IR. So I equals to V by R. Just compare this thing now. So is it V naught divided by 1 divided by omega c? So R equals to 1 divided by omega c. Done. So I equals to I naught sine omega t plus pi by 2. Now, from this equation, what you need to conclude that? So the resistance of pure capacitive circuit equals to capacitive reactance, that is xc, which is equals to 1 by omega c, which is equals to 1 divided by 2 pi fc. So you can see here the capacitance is inversely proportional to the frequency. If your graph is there, graph is rectangular hyperbola. Okay. Now you can see my I is in sine. I is in sine. One second. I is in sine and V is in sine also. So you can see here I equals to I naught sine omega t plus pi by 2, and V came out to be V naught sine omega t only. So what is phase difference now? Phase difference is you can see here, if I am doing I minus V, what is I is omega t plus pi by 2 minus omega t, cancel out, so my answer is pi by 2, but positive. You can write here current leads by pi by 2. So if it is current I, this would be my V. If this is my current I, this would be my V. So if you want to make a graph of it, no, if you have to make a graph of it, am I just going too fast? Am I going too fast? If you want to make a graph of it, this a V graph, then V graph, and current leads. So this is my current equation graph. Done. Now last part is there. We are having pure inductor now. We are having last part, third one now, and third one is what? Pure inductor. Pure inductor. Pure inductor. Look now. Use Ohm's law now. Sorry, use KVL. We'll use KVL. KVL. So I can write minus I L di by dt equals to V naught sine omega t. Sorry, it is plus. It is plus equals to 0. So that means I got as di equals to V naught by L. V naught by L. Then we are having sine omega t dt. Now integrate it. So I have I equals to, it is V naught by L, that omega, it is sine, it is minus cos omega t. So I can make it like I equals to V naught by omega times L. We are having sine omega t minus pi by 2. So pi by 2, right? So by this figure, what is phase difference now? Phase difference, you can see it is pi by 2. That means, 1 second, beta. Voltage leads by pi by 2. If it is my voltage, this is my current I. If you want to make a graph of it, if it is I, sorry, V. If this is V now, every time it is V now. So, but here, one thing is there, my V leads, okay? But here now, my V leads, it is V, so my current is here now. It is like this is my current equation. Done? Done? So now, by this thing, we completed phasor diagram, then pure resistor, pure capacitor, pure inductor. In pure resistor, no phase difference, no lagging leading. But in pure capacitor, current leads by 90 degree. Okay, but in pure inductor, V leads by 90 degree. So I guess we are done with today's class. Okay, now rest things we can discuss in tomorrow's class. I hope you enjoyed it, and in this particular week we will complete our AC also. Okay, in this week I am just hoping that I will complete my AC chapter also. Done? Easy or super easy? Easy or super easy? Easy, no? Okay, so thank you, beta. Thank you. Okay, bye, beta. Good night. Bye. Thank you.